Hi, welcome to my video on Radians. This is the unit on Radiance, and this is the first video. Radiance Part 1, Introduction to Radiance. Let's define what a radian is. A degree is the measure of an angle or rotation between two segments, rays, or lines. This is the angle measure is right here, and in the triangle we got a measure of this angle or this third angle, and we have again this angle, vertical opposite angles equals, we have this angle right here is equal to this one. So an angle is the measure between the rotation between the two lines. The measure of an angle between the initial and terminal arm of a rotation. So if you think about this circle and we're rotating from this point right here, so when we rotate up to here, then theta is the rotation in degrees, so this angle is equal to this the rotation on the arc. Central angle is equal to that, and also this circle has a center of 0, 0. So this is an angle measure of the rotation. But let's look at what a radian is. And a lot of students get confused and really don't understand about a radian. So I'm trying to see if I can clear it up a bit. A radian is the measure of an angle when the length of the arc on a circle is divided by the radius. Note distance on the circumference of a circle. So the length of the arc, it is the length of the arc divided by the radius. It's not the rotation. So theta in radians is the length of the arc divided by the radius. So theta is radians, S is arc length, and R is radius. So a radian measure is the arc length that's on a circle divided by the radius. And we keep that in mind. And again, the center of this circle on all circles that I'm going to do is 0, 0. So if we rotate from the initial position, and this is the radius, this point right here is r comma 0. So it's the length of the arc length from here to here, the length of that arc divided by the radius of the circle. That's what a radian is. Let's continue. Right now you're looking at a circle, like they're concentric circles. The O is the center of the circle, and the coordinates of this center is 0, 0. And I'll notice that all three circles have the same center. So we say circles that have the same center, like O, all these circles are concentric, and O is the center. So what we have is that this is the radius, so A is the radius of this circle right here. So this is 1, so the arc length is 1. So if we have a radius on circle, I'm going to call this circle 1. If the radius is 1 and the arc length is 1, then the radian measure is the arc length, which is 1, divided by 1. And the units, it makes no difference what the unit is, that the radian measure is 1 radian. And circle 2, this is circle 2. In circle 2, the radius is 1 plus 1, the radius is 2, and the length of this arc is 2. So it's 2 is the length of the arc divided by the radius, which is 2, so we have 1 radian measure. And notice, as if you have the same center, so this circle is twice as big, so the length of this arc and is twice as big as the length of this arc, but the radian measure is the same. And circle 3, which is this one, the radius is 1, 2, 3, and the length of the arc is 3. So the radian measure is the length of the arc, 3 divided by the radius is 1 radian. So 1 radian is the same on all of these circles. 1 radian is the length of the arc divided by the radius. So the radiant measure for all these circles, even though the distance traveled is different, but the radiant measure is the same. On any circle, theta in radians has a maximum value. So on any circle, circumference is 2 pi r. So circumference is the arc length. So the arc length is 2 pi r divided by r. So the r's cancel out, so you get 2 pi radians. So on any circle, the maximum arc length in radians is 2 pi. And let's do an example of a circle. Again, the circle, we're going to say the center is 0, 0. Has a 0, 0 center. So the radiant measure is the arc length divided by the radius. So the circumference divided by the radius, the arc length is the circumference. So it's 2 pi r times r. And so it's 2 pi. The radius is 4 centimeters. And the bottom is 4 centimeters because they're both radius. The 4 centimeters cancel out and you get 2 pi radians. So again, the maximum amount of radiant on any circle is 2 pi radians. Let's continue. The maximum radiant measure on any circle is 2 pi radians in terms of pi. But we know that pi, if you use your calculator, is approximately 3.14. That means the maximum radiant distance as a decimal is 2 pi, so it's 2 times 3.14. So the maximum radiant measure is 6.28 radians. And let's use this circle to illustrate this. Radians as a decimal. Notice radians can be in terms of pi, but also they can be expressed as a decimal. So as a decimal, so let's look at this circle right here. Let's look at the arc. So we have, no matter what the radius is, no matter what the radius of this circle is, the radiant measure is done by the length of the arc divided by the radius. So the arc length on this circle is, notice, AB is from here to here, right? And so that means that AB is 1/4 of the arc length. So it's 1/4 of 2 pi. So that's 1/4 of 6.28. And that works out to be 1.57 radians. Notice this is a 90-degree angle, and 90 degrees is 1/4 circle. So this radiant measure as far as here is 1.57 radians. And the arc AC is a half of the arc length, which is 2 pi. That makes it a half of 6.28, which is 3.14. So the radiant measure of AC, which is all the way over to here, that radiant measure is 3.14 radians. No matter what the radius of the circle is. If this circle got a radius of 10, then this length of the arc is 10 times bigger, and when you divide the radii cancel out. AD is 3/4. AD is right to here, so that's 3/4. AD is 3/4 of the total distance. So that's, when you do that, that's 3/4 of 6.28, and that works out to be 4.71 approximately. And again, this is not equal, I put an equal sign, but it's approximately. Put a little wiggle like like that, one wiggle, to say it's approximately, not really equal, but a wiggle. And AE is all the way around, so that's 1 times 2 pi, so that's 1 times 6.28, so that's, again, approximately 6.28, and I put radians in, radians, radians. So when you travel one complete revolution around a circle, you will travel 6.28 radians. If you go halfway, you get 3.14. If you go 1/4 of the way, you get a half of 3.14, which is 1.57. Now notice this is a 90, 180, and a 90. So if you went this distance, 3.14, and added on 1.57, you would get D to be 4.71 radians. I didn't put that in just then. So 90 plus 180, the two of these added together gives me this one, or it's 3/4 of the total, 6.28. Okay, let's continue. Again, radiant measure is the length of the arc divided by the radius of the circle. It's the distance on the arc. And let's continue. The radius of this circle is R units. Don't mean there was 1 centimeter, 2 centimeters, 3 centimeters, or it was 5 feet, 10 feet, 20 feet. Then this is 0 radians right here because we haven't rotated. This is 1.57 radians. This is 3.14 radians. And this is 4.71 radians. And when you rotate all the way around, the most radians is 6.28 radians as a decimal. Remember, we'll come back to these again later, but I want to emphasize the decimal for these. And note that this is pi over 2, this is pi, this is 3 pi over 2, and that's 2 pi. But we'll come back to this, if you can see it, this is 2 pi radians. And this distance, this radian measure here is 3.14 or pi. And this radian measure here is 1.57, or it's pi, which is this, divided by 2 is half of it, pi over 2. And this is 3 pi over 2. It's 3/90. Okay, where is each approximately? Name the letter. Where is approximately 1 radian? So the letter that represents 1 radian, 1.57 radians, and there's 0. So 1 is approximately the letter H, approximately H. So if you rotate on this circle as far as here, and the radius, so the length of that arc divided by the radius, you'll get 1 radian on your rotation. 2 radians, that's 1.57. So 2 radians is a little bit more than 1.57. So V is approximately representing 2 radians. 3 radians, again, if you rotate right to here, that's 1.14. And 3 radians is approximately right there, T. Radians. And 4 radians, well, this is 3.14 as far as here. This is 4.71. So 4 radians will be W, approximately representing W. 4 radians is in between 3.14 and 4.71. 5 radians, this is 4.71. 5 radians is more than, so the letter K is approximately representing 5 radians. And 6 radians, 6.28 is all the way around, and so 6 radians would be almost to there, so the letter L is representing 6 radians. Again, a radiant. Calculate the radiant measure of each. So a radiant is defined as the arc length divided by the radius of the circle. Keep that in mind. I gotta memorize it. So let's do these examples. we got an arc length, we have a radius, and we have the radiant measure. So if the arc length is 1 centimeter and the radius is 1 centimeter, then the radiant measure is the arc length, which is 1 centimeter, divided by the radius, which is 1 centimeter. And so the radiant measure is 1 radian. So it makes no difference if you draw a circle and you wrote, this is one radius of 1 from here to here. Remember, the center is 0, 0. If you rotate up on your circle 1 centimeter, like that, then the radiant measure, if you draw a terminal arm, then the radiant measure, that's rotation of 1. So this rotation in relation to theta is 1 radian. B, we have a circle with an arc length of 18 meters, and we have a radius of 9 meters. So again, I'm going to draw another circle. It's not drawn exactly to proportion, as you can see. But if the radius of this circle is 9, and just draw your attention to this point right here, that radius is 1, this point is 1, 0. If this radius is 9, that means that this point here is 9, 0. So if we rotate 18, so let's see, the arc length is 18 meters, divided by the radius is 9 meters, so we have 2 radians. And note that 1.57 is here, so if you rotate up 2 radians, that's 1.57, so you're somewhere in here. So there's 2 radians. If you draw your terminal arm, so this rotation is 2 radians. That means this angle rotation in here is 2 radians. So this rotation is the same as this 2 radians. And C, we have a 22-inch arc length with a 4-inch radius. Again, let's draw the circle. The radius is 4. That means this point here is 4, 0. So the radius is 4. And we're going to rotate 22. So 22 is the arc length. The radius is 4 inches. And you divide. The inches cancel out. Meters cancel out. Centimeters cancel out. 4 into 22 is 5.5 radians. And if you think about it, right here, this radian measure here is 1.57. The radian measure as far as here is 3.14. The radiant measure to here is 4.71. So 5.5 would be a little bit more, would be over here. So this rotation right around is the radiant measure. So that rotation is 5.5. The terminal arm goes out through there. So again, this rotation that I just traced out is 5.5 radians. And I remind you, 0 radians, 1.57, 1/4 of the way. Half the way is 3.14. 3/4 of the way is 4.71, and all the way around in terms of radiant is 6.28. Keep these numbers in your mind. Learn them. You'll need them. And again, do your teacher do the radiant in terms of a decimal? Well, check with your teacher. But I'm going to do more work on this in the next video, relating the radiant to a degree and doing more work. Or I'll do it on the next sheet also. Calculate each radiant. All the units are centimeters. Now, if you look at this circle, again, the center of the circle is understood to be 0, 0. Now notice this point A is 2, 0. That means the radius of the circle is 2. Again, if this point is 2, 0, the radius of the circle is 2. The arc length AC is 2, 2.2, I'm trying to say, 2.2. Again, the units are centimeters. So the radius is centimeters. So the radian measure, again, is defined as the arc length divided by the radius. So the arc length is 2.2 centimeters divided by the radius, which is 2 centimeters, and you get 2 into 2, 1, 2 into 2 goes once, 1.1 radians. So this distance here, if you draw a terminal arm, this is 1.1 radians. So the rotation in here is 1.1 radians. And we have another circle. And notice that this point at H is 3, 0. So that means the radius of the circle is 3. So the radius is 3, and the units are centimeters. So the arc length, THT, which is this rotation, is 6.9 centimeters. So the radiant measure is the arc length divided by the radius. So the arc length is 6.9 centimeters divided by 3 centimeters. Centimeters cancel, and I get 2.3. Oh, I'm going to mark 2.3 radians. Centimeters cancel out, 2.3 radians. So again, if you draw, the center is 0, 0. And if you draw a terminal arm out through like that, then this rotation here is 2.3 radians. And that means this angle in here is the same, so that's 2.3 radians. So a radian measure is the arc length divided by the radius of the circle. And we have more to do. Again, you can pause your video if you want. Work out the arc length for these. Find the arc length of the circle. If the radius is 1.2, the radiant measure is 1.2 and the radius is 4. Well, we have the theta radiant is the arc length divided by the radius. So the radiant measure is 1.2 and the radius is 4. And you put it over 1, if you cross multiply, 1 times s is s, and you get 4 feet times 1.1. So the arc length is 4.8 feet. Just using the formula here and subbing in. Just then we found the radiant measure. Now we're reversing it and find the arc length. And so the radiant measure, I always write it down, is the arc length divided by the radius. So the arc length, we're trying to find the arc length. The radiant measure is 3, which is right here, and the radius is 6.1 millimeters. So what's the arc length? Put it over 1, cross multiply. 1 times s is s. So we get 3 times 6.1 millimeters, and that gives us 3 6 are 18.3 millimeters. So we're just switching the formula around, because in order to work this out, you need 2 of these to work out the third. And we need to find the arc length again. So the radiant measure is the S is the arc length divided by the radius. The radiant measure is 5.6, and the arc length S, and the radius is 8 meters. Make that 8 bigger. Put it over 1, cross 1 times S is S, and you get 5.6 times 8 meters, and that gives you 44.8 meters. You can use your calculator on that. and work out 44.8. So again, in this one, I'm just reversing, giving you two of these, and you got to find the third one. And also, we can have a negative radiant measure. Again, the center of the circle is 0, 0. So this is the positive radiant measure. So now this is the negative one going this way. So if you use the arc AC right here, now, so this is, if you're going this way, this is 1.57, but is negative. This one is 3.14, but is negative. If you're going to get the negative radiant, so the arc AC is negative 3.4. This one is 4 point, and to memorize it, 4.71. In other words, add the two of these together, and you'll get that one. So that's negative. And this is a negative 6.28 radians. So AB is negative 1.57 radians. AC is a negative 3.14 radians. AD is a negative 4.71 radians. And AE, you're going from A to E, it's negative 6.28 radians. Okay, here we go. And again, it makes no difference what the radius of the circle is, because it's the arc length divided by the radius. Now, calculate the radiant measure of each. So notice we have a circle. Again, the center of the circle is 0, 0. Notice that the radius of this point is 2, 0. So that means the radius is 2. So the radiant measure is the arc length is AP. AP, notice AP is negative. So is the arc length divided by the radius. So that's 2.84, but is negative because you're going clockwise. And is divided by the radius of 2. And so again, it's in meters. So it's meters, meters. So when you divide that out, you get a negative 1.42 radians. So it's the same as before, only it's a negative rotation this time. And on this circle, again, the center of the circle is understood to be 0, 0. And so this is a 10, 0. So the radius is 10. So the radius of this circle is 10. And notice if the arc is in inches, so let's say the radius is in inches. And so the radiant measure is the arc length divided by the radius. So the arc length of AW, notice AW is going this far right here, and is negative, so it's a negative 45 inches. And the radius of the circle is 10 inches. And to divide, you get a negative 4.5. The inches cancel out. Notice radians have no length to it. Radians is, because the inches canceled out, the meters cancel out. So radians is just 1.57, 3.14, 6, etc., etc. So that's the introduction to the concept of a radiant in trig. Hopefully you understand. Again, just to make sure, the radiant measure is the length of the arc divided by the radius. And the most you can have is 6.28 radians, which is 2 pi radians. So 2 pi radians is the same as 6.28 radians. That's one complete rotation right around. And if you like my video, click the like button, subscribe button. Visit my website, www.mathfullyexplained.com. to find more information about me, my video, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.